Membrane bioreactors are usually known as a wastewater treatment technology, but experts today are finding ways to leverage their efficiency for potable reuse projects. MBR expert Anthony Zamarro sat down to share why this technology is transforming how we clean water. Check it out.
I always say MBR is the high-tech end of a low-tech industry, right? In water and wastewater, we're very conservative because we're responsible for public health. And we want the latest technology, but we also want what's proven, reliable, safe. And membrane bioreactors have just been a great story because the innovation that's happened incrementally over the last 20 years or so, which is the horizon over which this technology has been adopted, has been really amazing to the point now where we get predictable outcomes with membrane bioreactors. That's a new thing, new in the last 10 years or so. There's continuing innovation around energy savings, around more economical configurations of the technology, new membrane formulations. So it's really interesting. It's a really interesting mix of, a very kind of conservative technology field with high technology.
Why are MBRs being applied to potable reuse, and what are their benefits?
So what MBR does, it's an enabling technology in two ways. It's great at pathogen removal. So pathogens are microscopic, kind of the really bad actors that we focus on are on the scale of 1 to 3 microns in size. So an MBR properly operated will remove those particles. It's also an enabling technology in the sense that it's creating a really great starting point for the advanced treatment system that then is going to remove contaminants that are sub-micron in size. So these are contaminants of emerging concern like PFAS, like CECs, like pharmaceutical products, hormonal byproducts from human waste, industrial pathogens or industrial chemicals that could be in the water. So MBR provides a starting point for processes like reverse osmosis that would treat those more challenging chemicals. I was involved in a study with another one of our engineers, Dave McNevin, down in Florida, and he did a direct potable reuse sampling plan for one of our clients. And the actual scale of contaminants that you're looking at in a direct potable reuse project are in the order of 250 different constituents. So MBRs are removing some of the kind of the worst actors that we're aware of, but what it's doing is just creating an effluent that an advanced treatment train can act on efficiently, and then it's removing the other 245 constituents that we're concerned about in a potable reuse train. So we're talking technologies like reverse osmosis, advanced oxidation, and things like that are targeting CECs, pharmaceutical byproducts, and other kind of organic constituents that are kind of sub-micron in scale.
If you want to learn more about strengthening your water supply portfolio through reuse and desalination, check out cdmsmith.com/reuse. Okay, back to Anthony. Where do you see MBRs having the biggest impact on potable reuse projects?
The big direct potable reuse projects that are underway in Southern California. So there's 3 projects currently being considered that total 1 billion gallons a day of capacity in Southern California. So it's the city of San Diego, the city of Los Angeles, and Los Angeles County. Between those 3, and they're all using membrane bioreactors as their tertiary filtration step before advanced treatment. So those treatment processes, when you visit Southern California, I come from New England, when you drive around New England, everything is green. We take water for granted here. And when you drive around the Southwest, especially in the summer, you really see the lack of water. It's really evident, especially in cities like Phoenix, San Diego. So it's really amazing to think of the transformative effects that these direct potable reuse projects are going to have. And again, membrane bioreactors in a lot of ways it's just one piece of the direct potable reuse puzzle, but it's a real enabler that's going to enable these projects to move forward. Without membrane bioreactors, they really wouldn't be able to scale these projects the way that they are.
Anthony, thank you so much for being here today. It was great to talk to you.
Yeah, my pleasure. It's a topic I love to talk about, and I'm glad you guys asked. Thank you very much.